Okay, chapter 2-3, synthetic division. Synthetic division is wonderful. It is going to be your best friend. You're going to love it. Does everybody have a calculator with them today? Okay, you need to have your calculator out because we're going to do a lot of numerical calculations. And if your numerical calculations are not correct, your whole entire problem will be thrown off. Okay? Synthetic division is a shortcut for long division. However, it can only be used on a degree of 1. So an x minus a k. So if we look on page 1, 2, 3 in our textbook, and that was last week's homework, which was at the beginning of this week, Mondays. If you look on page 1, 2, 3, problems 1. Tyler, pass your book down for me, would you? Thanks. Okay, problem number 1 is divided by x plus 3. Since that is degree 1, I can use synthetic division on it. Problem 2 is divided by x minus 4. Can I use synthetic division on that? Yes. How about problem 6? It's divided by 2x plus 1. Is it degree 1? 2x to the first power plus 1, is that degree 1? Yes, so I can still use synthetic division. Okay, well, what about number 7? Number 7 is divided by 2x squared plus 1. I cannot do synthetic division on that. I have got to do long division because it's degree 2. What about number 10? I'm dividing by x cubed minus 1. Can I use synthetic division on that? No, I have to do long division. Do we all understand when you can and when you cannot use synthetic division? Wonderful. Okay, with that being said, we're going to go ahead. And I need to talk to you about the factor theorem. The factor theorem is going to be if f of k is equal to 0, then f of x is a factor, and that factor is x minus k. Now, this one right here, we're going to do long division. Why? Because that's what you know. So if I do long division on this polynomial, I have x minus 5 on the outside. And on the inside, I have 3x cubed minus 17x squared plus 15x minus 25. I am not missing any powers, so I don't have to put any placeholders in. Do we all understand that? Okay. Now, with that being said, what do I multiply x by to obtain 3x cubed? 3x squared. I put that over the x squared position, and on the diagonal, I multiply. So that's 3x cubed minus 15x squared. Then, what am I going to do vertically? I'm going to subtract them, which means I'm simply changing the signs of the bottom polynomial. That cancels out, and this gives me a negative 2x squared plus 15x minus 25. Now, what do I multiply x by to obtain a negative 2x squared? Negative 2x. Multiply on the diagonal, negative 2x times x gives you a negative 2x squared. Negative 2x times negative 5 gives me a positive 10x. And I'm going to go ahead and I'm going to change those signs to make that a positive 2x and a negative 10. Those cancel out, and I have 5x minus 25. Yes? Okay, so we're going to do it again. What do I multiply x by to obtain 5x? A 5. 5 times x is 5x. 5 times negative 5 is negative 25. And we're going to go ahead and change those signs. And that tells me that my remainder is 0. Which indeed shows that x minus 5 is a factor of that polynomial. Do we understand that, yes or no? Okay, we're going to do the same exact problem, but we're going to do this by synthetic division. So the very first thing you're going to do is you're going to take x minus 5 and set that equal to 0 and solve for x. So x minus 5 is set equal to 0, and I'm simply going to add 5 to both sides. So what I'm going to do synthetic division at is the value 5. We're going to put 5 in a half box. We're going to put 5 in a half box. And now what we're going to do is we're going to drop down only the coefficients of the variables as well as the constant. I want to see no variables in there. Do you all understand that? So 3x cubed, I drop down to 3. Minus 17x squared, I drop down to minus 17. Plus 15x, I drop down to 15. And minus the constant of minus 25. Do we all understand that? Now, what I'm going to do is I'm going to simply check my degree. Degree 3, 2, 1, 0. I am not missing any powers, so I'm okay. Do we all understand that? Now, what you are going to do is you are going to draw a line here. The very first thing you do is you drop down the 3. Then on the diagonal, you are going to multiply 5 times 3, which gives you a 15. And then you are going to add vertically. What is negative 17 plus 15? Negative 2. Then what do you do on the diagonal? What do we do on the diagonal? Nope. Multiply on the diagonal again. So 5 times negative 2 is going to be negative 10. And then vertically we add to give me a 5. Diagonally we multiply. 5 times 5 is 25. Vertically we add to give you 0. Now, 0, this number right here that I boxed in is what we call the remainder. And when we did long division, what did we know about our remainder when we did long division in the last example? What was my remainder in the last example? 0. So we knew that this thing was a factor. Well, guess what? We still know this is a factor because my remainder is 0. Now, here's what I need your brain to understand. This is degree 3, yes? As soon as you do synthetic division one time, it drops it down a degree. So I'm now from degree 3 down to degree 2. So we're simply going to put our variables back on these coefficients. So this is going to be a 3x squared. Why? Because it's degree 2. Minus 2x plus 5. And that is your answer. Now, do you notice that those two red boxes are indeed exactly the same? One was done by long division, the other was done by synthetic division. They're still exactly the same answer with exactly the same remainder. Do we all understand that? Synthetic division is super duper easier, right? No? Well, you're going to get used to it. You'll like it afterwards, I promise. So here we go. We're going to do number 2 on tonight's homework. And the directions on number 2 in tonight's homework says use synthetic division to divide. Now I'll go ahead and pass out your homework to you now. I want you to go ahead and keep doing these in your notes, because that way you can read the directions and you know exactly what the directions are stating in tonight's homework. So the directions say use synthetic division to divide. So the very first thing you're going to do is you're going to take the divisor, which is x plus 2, and set that equal to 0. And you're going to solve that for x. So what do? Subtract 2. So x is equal to negative 2. Negative 2 is what's going to go in the half box. Negative 2 is what goes in the half box. Now from there, we're going to drop down our coefficients, making sure that if we're missing variables, that we put in a space holder of a 0. Do we all understand that? So I have 5x cubed. So I have a 5. Do I have an x squared? Nope, so I put a placeholder of a 0 in there. Do I have an x to the first? Yes, that's a 6, and then my constant is an 8. So what you're going to do is you're going to simply look at your degree, which is a 3, and you're going to count down 3, 2, 1, 0. And I know I'm okay. We all understand that I did not miss any placeholders. Okay? So I'm going to draw a line here. Very first thing you're going to do is drop down the 5. Yes? Now what do we do on the diagonal? You multiply. 5 times negative 2 is 10, negative 10. What do I do vertically? Add 0 and negative 10 can be negative 10. Diagonally, I multiply. Negative 2 times negative 10 is 20. Vertically, I add. 6 and 20 is 26. Diagonal, I multiply. That's going to give me a negative 52. Plus 8 is going to give me a negative 44. This is what we call the remainder. Now, is 2 or negative 2 a factor of this polynomial? Why is this not a factor? Because the remainder was not 0. Do we all understand that? So since the remainder was not 0, I know this thing is not a factor. But that's not going to stop us from going ahead and writing a polynomial. I know this thing is degree 3, so as soon as I do synthetic division one time, what degree does it drop down to? Goes from degree 3 to degree 2. We all understand that. So we're going to go ahead and put on our missing variables. So that's 5x squared minus 10x plus 26. And this is going to be plus a negative 44 over the divisor, which is x plus 2. And this is how we did long division on Monday in our notes, yes? This is how you are going to do problems 1 through 4 on tonight's homework. Any questions on 1 through 4? We good? Okay, now we're going to continue along. However, what you need to understand is there's many different forms that you can write things. In the past, I've said solve and find the x-intercept. In the past, I've said factor completely and not solve, right? And then other times I've just said straight up divide, correct? So all of those terms mean something different to you in your head. Now, the directions are a little bit different now. The directions are going to say, hey, I want you to rewrite this thing. And I want you to rewrite this thing so that whenever you do this, you are factoring out the x minus k. You have what remains here after you do the division plus your remainder at the very end. So we're still going to do this exactly the way we did before. So x plus 1/2 is equal to 0. So how do I solve this? Minus 1/2. Now what goes in the box, in the half box? Negative 1/2 goes in the half box. And I'm going to simply bring down only my lovely little numbers on my off my variables. So 4x cubed, 16x squared, minus 23x, minus 16. And what do I always do after I do that? Check to make sure you're not missing any space holders. So here this is going to be 4x cubed, 16x squared, x to the first with a negative 23, and then my constant. I'm not missing anything. Do we all understand that? So I'm simply going to do the math now. What do I do first? Drop down the 4. What do I do on the diagonal? 4 times negative 1/2 is going to be negative 2 plus 16 gives me a 14. Gives me what? 14 times negative 1/2, it gives you what? Negative 7. And negative 23 gives you? Times negative 1/2 gives you a positive 15. So if you add that to the negative 16, what do we have here? A negative 1. What can you conclude? That our remainder is negative 1, implying that this is not a factor of that polynomial. Do we all understand that? Okay. Now, what we're going to do is we're going to take what we originally had, which is the x plus 2, or the x plus the 1/2. And I'm going to write this in factor forms. This is going to be x plus the 1/2. When you do this, what degree is this polynomial going to turn into down here? It was degree 3, so now it's going to be degree 2. And I simply am going to attach this by multiplication. So that's going to be 4x squared plus 14x minus 30 minus a 1. And that's simply writing it in a different form. Are we good? We good? Okay. So I think I'm going to skip down. I'm going to do number 7 because I think we've done enough problems where we actually did it with numbers, right? We're going to do it with lovely little irrational numbers. So everybody needs their calculator out. This time this says that k is equal to 2 plus the square root of x. You know what? This is normally x minus k, isn't it? Okay? What this means is this is what goes in the half box. They already solved it for you. So what we have going in the half box is 2 plus the square root of 2. Do we all see that, yes or no? I'm going to simply drop down my lovely numbers off my variables. That's negative 3x cubed plus 8x squared plus 10x minus 8. We good? Okay, now I'm actually going to spread this out a little bit further because we need a little bit more space in here because we have to have a part for a real number and an irrational number. Do we see that? Now, before we begin, I'm going to check my powers. 3, 2, 1, 0. Since I was able to get down to 0, I'm not missing anything. I know I'm good. Okay, so now I'm going to go ahead and I'm going to drop down the negative 3. Okay? Now, I'm adding another page so that you can see what I'm actually doing. We're going to multiply on the diagonal. So that's going to be negative 3 parentheses 2 plus the square root of 2. That's going to give you a negative 6 minus 3 square root of 2. Do we see that? Yes or no? Because we're multiplying this on the diagonal. Do we see that? Are we good? Okay. So that's what I'm going to come over here. I'm going to put the negative 6 under the negative 8, under the 8. And this is negative 3 square roots of 2. Okay, now I'm going to add straight down. I can only add the real numbers together. The rational numbers with the rational numbers, the irrational numbers with the irrational numbers. So this is going to give me 8 take away 6 is going to be a 2 minus 3 square root of 2. Do we see that, yes or no? Now, diagonally, I need to do this again. So I'm going to take 2 plus the square root of 2 times 2 minus 3 square roots of 2. Do we see that, yes or no? So I'm going to FOIL that. I can't do this on the calculator because the calculator is going to give us irrational numbers, decimals. So this is going to give me a 4 minus 6 square roots of 2 plus 2 square roots of 2 minus 3 square root of 2 times the square root of 2 is just going to be 2. Do we see that? Let me go ahead and make that the square root of 4. Okay? Just so that you all understand where that 2 came from. Okay? So if I combine like terms, this is going to be 4 minus 4 square root of 2 minus, this comes out as a 2, so that's a 6. 4 minus 6 gives you what? 4 minus 6 is going to give you a negative 2 minus 4 square roots of 2. That is what's going to go right here. So I have a negative 2 minus a 4 square root of 2. So what is 10 take away 2? Yep. So now I have to do this all over again. So that's going to be 2 plus the square root of 2 times 8 minus 4 square roots of 2. Yes? So that's 16 minus 8 square roots of 2 plus 8 square roots of 2 minus 4 times 2. Yes? This right here is going to give me a minus 8. So 16 take away 8 is going to be 8. Negative 8 and negative 8, those cancel out to just give you an 8. And that gives me 0. What does that imply? It's a root. There's no remainder. Do we understand that? So how do I write this in its factored form whenever I have something that is that ugly? Well, the way you're going to do that is you're simply going to have parentheses around each one of those. So what you're going to write, what degree does this turn into? Degree 2. So I'm going to go ahead and have x minus 2 minus the square roots of 2. Do you see that? I'm bringing the 2 and the square root of 2 on the same side as the x. Negative 3x squared plus 2 minus 3 square roots of 2 times x plus 8 minus 4 square roots of 2. You see how I write that? This right here is a number. It's a decimal that goes on forever. It's an irrational number. Do we see that? And that happens to be the coefficient of my x term. Is it ugly? Yes. Does it work? Yes. Do we understand that problem? That is how you're going to do problems 5 through 8. Like 5 through 8 on the homework. It can, it doesn't matter, but you absolutely can if you want to. Okay, now, the next thing that you need to know about is going to be q of x equals 2x to the fourth minus x cubed plus 2x minus 1. If I tell you to do q at 3, what are you going to do? Plug 3 in for what? X. So that's going to give you a 2 parentheses 3 to the fourth minus 3 cubed plus 2 times 3 minus 1. Correct? Nine times 9 is going to be, all right, 3 times 3 is 9, 9 times 9 is 81, 81 times 2 is going to be 162, minus 3 times 3 is 9 times 3 is 27, plus 6 minus 1. If you add all of that together, it's going to give you 140. Now here's what I'm telling you. When you do synthetic division, the remainder will always be the evaluation. The remainder is equal to the evaluation. F at that x. Whatever x is, it is the evaluation of that. Okay? So that means that the remainder is equal to f at k. Right? So what do I mean by that? Let's go ahead and do the same problem now I just did with plug and chug, but let's do it with synthetic division now. So if I'm doing that with synthetic division, I'm going to go ahead and put a 3 inside the half box. And I'm going to start dropping down variables, the coefficients, right? So this is going to be a 2x to the fourth minus 1x cubed. Do I have an x squared? 0. 2x minus 1. Let's drop down the 2. I'm going to check this first. 4, 3, 2, 1, 0. I'm not missing any terms, so I know I'm right. Drop down the 2. 2 times 3 is 6. Add, that gives me a 5. 5 times 3 is 15. Add, that gives me a 15. 15 times 3 is 45. Plus 2 is going to be 47. 47 times 3 is 141. Subtract 1, that gives me 140. That's pretty sweet, right? Isn't that kind of cool? So Q at 3 is 140. Why? Because that's the remainder when I did synthetic division. So is this thing a factor? Is this thing a factor? No, it's not a factor because my remainder is not 0, but F at 3 is 140. Do we all understand that? This is how you're going to do 9 through 10 on the homework. Number 9. Ready? I want to know what F at negative 2 is. So I'm going to put negative 2 in the half box. And I'm going to start putting my coefficients. So that's 1x to the 6th. Do I have any x to the 5th? So what do I have? 0. Minus 4x to the 4th. Plus 0. That shouldn't be a plus there. Plus 0x cubed. Plus 3x squared. plus 2. Drop the 1 down. 1 times negative 2 is negative 2. Plus 0 is negative 2. Times negative 2 is going to be 4. Add them together, that gives you 0. 0 times anything is 0. Plus 0 is 0. 0 times negative 2 is 0. Plus 3 is 3. Times negative 2 is negative 6. Plus 2 is negative 4. Did I screw up anywhere? Did I? I didn't check. Good example as to why we screwed up. You guys did not remind me to check. I should check. Now, he's absolutely right. Right at the spot right here, I missed the 0. So there needs to be a 0 and then a 2. And if we check that, that's going to be 6, 5, 4, 3, 2, 1, 0. And I did not check that. And that should give you a dead giveaway that, oh, I screwed up. So 3 times negative 2 is negative 6. Negative 6 times negative 2 is going to be 12. That gives you a 14, and that looks so much better. It's always good to mess up every once in a while, right? Keeps you humble. Good job, Jaden. Thank you for finding my mistake. Do we all understand that, yes or no? Okay, so what can you conclude? F at negative 2 is simply equal to 14. Again, this is how you're going to do 9 and 10. Any questions? Okay, let's go on to the next one. It says use synthetic division to show that x is a solution of the third degree. Whoa, what does that mean? X is a solution of the third degree polynomial. What does that mean? That in this specific problem, that x minus 2 is a factor, meaning x equals 2 is a root or an x-intercept of this problem. Do we all understand that? So according to synthetic division, what does that mean that I should have with my problem? Synthetic division. What's important about synthetic division? What's the last number in synthetic division? Your remainder. So if this thing is a root or a solution, what should my remainder be? Guys, the factor theorem says that your remainder should be 0 if it is a root or an x-intercept or a solution, however many ways you want to say it. Okay, so whenever I do synthetic division at 2, it's telling me that this is an answer to that problem, which means it has to have a remainder of 0. Do we all understand that? If you don't get 0 as your remainder, you've screwed up. Now, the other thing is it says it's degree 3. So since it's degree 3, how many solutions should this thing have? If the degree is 3, how many solutions should this thing have? Take a stab in the dark. 3. Right, 3. Remember when we did the leading coefficient test? We looked at the degree, we said, hey, it's degree 5, so therefore it's going to have 5 zeros. Hey, it's degree 4, it's going to have 4 zeros. Hey, it's degree 3, it's going to have 3 zeros. Do you remember we talked about that? Same exact thing. This is degree 3, so what is the polynomial? How many answers is it going to have? 3. It wants you to find all 3 answers. So it says, show that x is the solution of the third degree polynomial, meaning it has a 0 as its remainder, and use the result to factor the polynomial completely. So after you've done synthetic division, you're going to get a new polynomial. I want you to factor that into 2 binomials and find the remaining zeros. Do we understand that? So here we go. We put 2 on the outside. Degree is 3, so this is 2x cubed minus 15x squared, 27x minus 10. I'm not going to make the same mistake I made last time. So 3, 2, 1, 0. I know I'm okay. Yes? Or just give it a minute today. Drop down the 2. 2 times 2 is 4. 4 and negative 15 is negative 11. Negative 11 times 2 is negative 22. 27 and negative 22 is going to be 5. 5 times 2 is 10, and that gives me a 0. What did I conclude? Thank you. The remainder is 0, so that means this is a factor. Now, as soon as I do the lovely synthetic division, what degree does this drop this thing down to? Drops it down to degree 2. Do we understand that? So that is 2x squared minus 11x plus 5. And I'm going to set that thing equal to 0 because I want to factor that completely. So how do I factor that thing? Put it into 2 binomials. So how do I break down 2x squared? Factors of 5. 1 and 5. Where does the 5 go? 5 goes on the outside, and the 1 goes here. I need to have a positive 5, so my signs have to be plus, plus, or minus, minus. Which one are they going to be? Minus, minus. So that means 2x minus 1 is a factor, and x minus 5 is a factor. So x is equal to 1/2, and x is equal to 5. And we already know that x equals 2 is my other root. So I found all 3 roots. However, it says to factor the polynomial completely. So my factored form is going to be x minus 2, x minus 5, and 2x minus 1. Would you like to do a homework problem? Okay, this is number 14. It is easier to just go ahead and have the calculator out so that you do not make mistakes than it is to not have the calculator out. Because this is all numerical analysis. This is not a difficult process, but if you don't have the correct numbers, it screws up your whole answer. So, I'm telling you that 2/3 is an answer. This is 48x cubed minus 80x squared plus 41x minus 6. Go ahead and check your powers. 3, 2, 1, 0. I am not missing any terms. So I'm going to go ahead and I'm going to drop the 48 down. So take 48 times 2/3. And what does that give you? 32. Minus 80 gives you negative 48. Times 2/3 gives you negative 32. Plus 41 gives you 9 times 2/3 gives you to give you a remainder of 0. Our remainder better than 0. Why do I need my remainder to be 0? Because it is a factor. So this turns out to be degree 2 now. So I have 48x squared minus 48x plus 9 is equal to 0. Do we see that? Yes or no? Do I have a GCF? Do I have a number in common between 9 and 48? 3. So can I pull out a 3 to make this life a little bit easier on myself? Yes. 48 divided by 3 is 16x squared minus 16x plus 3. Yes? Do we all understand that? Now I'm going to break this down into two binomials, if at all possible. So that's going to be a 4x and a 4x, 3 and a 1. And inner gives me a negative, that's going to give me a 12. I have to have a positive 3, sorry. So that gives me a plus plus or a minus minus. So if I'm going to add them, that's going to be minus minus. Inner gives me a 4x, outer gives me a negative 12x to give me a negative 16x. So 4x minus 1 is equal to 0, and 4x minus 3 is equal to 0. So x is equal to 3/4, and x is equal to 1/4. And we already know that x equals 2/3 is another answer. So I found all my roots. So my factored form is going to be x minus 2/3, x minus 1/4, and x minus 3/4. You could put that, or you could make this 3x minus 2, 4x minus 1, or 4x minus 3. They're all the same. You know what today's homework is? Have a great day. I passed it out, correct? Your homework?